button here.
Available, sir.
Share screen. There's
Shares. I see chat.
share screen. There's a.
I make you, sir, co-host also.
I don't see in my profile. Okay, I found it out. Okay. Okay. So, okay. So do you see this file? There is something called driving force behind technological innovation. Can you see?
Yes, okay.
Okay, fine. So at this moment, in our university, there is no mechanical engineering department. We have division of mechanical and electrical engineering, because nowadays our Ministry of Education actually wants more cross-discipline rather than the old disciplines. So I'm in the division of mechanical and electrical engineering. And I'm the chairman of a department called Intelligent Machines and Biomechanics. And I'm the director of Manufacturing Center, and also the director of Advanced Manufacturing Engineering Laboratory. We have around 22 students, 4 students from different countries: Iran, Indonesia, Bangladesh, Mongolia, and there are 3-4 students who will join me next year. And also we have 15 Japanese students. And most of the students are actually involved in inventing technology, not using the current technology. So how can you become an inventor? By the way, this is our lab website. If you would like to go and see, you can. You see, the human being can invent, not any other animal can invent. And human being actually works in three spheres. One is we call idealism, the other is called realism, and the other is pragmatism. Idealism means you have something, truth, that you cannot challenge. You take it as a granted, this is true for you. Realism, that you deal with the real world. So most of the times, one mistake we make, we think that if I am in the real world, I will be a very good inventor. The answer is no. If you would like to be an inventor, you have to be in the pragmatic world. Pragmatic world means something that you think this is true. And if you are in the pragmatic mode, you will be a doer, not a knower. This is a common mistake. We think that we study in the university, we study many different books, we are a very good student, we can innovate. The answer is no. If you study in the university, if you read many books, you will be a knower. You will know. That means either you will be in the idealism or you will be in the realism. Pragmatism will not come to you. If you would like to be an inventor, you must have to be a doer. You have to do something. And once you do, you will find that you are doing mistakes. People are criticizing you. So you must have to have the guts to say, look, you can criticize, but this is what I think I should do now. Probably after doing more, I will be able to explain you more. So please wait. So this is very important for technological innovation. If you read carefully the paper the last paper that Professor Nawaz Sharif wrote, Professor Nawaz Sharif has shown clearly that Koreans were very good to implement the plan, whereas Pakistanis, they are very good to writing down the plan. So writing down the plan means you are a knower. You know many things. And implementing the plan, you are a doer. You might do a lot of mistakes. In our day-to-day life, politicians are actually doers. You always criticize politicians. They always do mistakes, but they are the main driving force behind all our societal activities. Okay, so this is a very shocking, I would say, this is a very shocking way of thinking about innovation, because we think that if we study many things in the university and listen to our professor, we will be able to be a very good technological inventor. The answer is no. Okay, you have to be pragmatic, you have to be a doer rather than a knower. So this is the first message I would like to convey to you. Now, what will make you a doer? So we need some tools so that we can come out from the world of knower to doer. We are actually trying to develop those tools. Today, I'm not going to talk about what we developed ourselves. I will give you a very simple and well-known theory. We call it theory of inventive problem solving, or trees. It's the word trees is coming from a word written in Russian. One guy from Russian patent office, Altshuler, he studied more than 200,000 patents and tried to see how people invented. And based on his observation, he gave a theory which is known as theory of inventive problem solving, TRACE. So this could be a starting point of you to become a technological inventor. You try to apply trees, that will make you a good inventor. However, there are many problems with that. I'm not going to talk about the problem. I'm just going to show you how you can apply trees. And once you are familiar with trees, then you will be able to grasp or know about other theories or tools for technological innovation. So those things I will not talk today. Probably in some other time, if you give me time, I will be able to give you some idea of it. So what Altshuler found? Altshuler found that most of the technological innovation that has been patented is step-by-step apparent solution. So if you are if you studied in the university, probably you will follow some step-by-step apparent solution. And 32% of the patent was those kind of things, step-by-step apparent solution. You just follow a standard rule and you somehow come up with something new. So then you go for patent. And 45% of the patent he found minor improvement. So who could do that? Exercise within company. So you have some working experience. measure improvement only less than 20%. Broad knowledge of the industry. This is what Al-Schuler is saying. And new concept and solution, knowledge outside the industry. If you have, then you will do that. And it's rare. And discovery, God gifted. You never know why you came to this solution. What was the knowledge behind coming to that solution? So that's why I'm saying that if you would like to be an inventor, or you would like to be an inventor for technological innovation, first you have to delete the knowledge that you have gained. And you have to be a doer rather than a knower. So knowledge will come after you're doing something. And that knowledge might not be what is written in the book. So people might not accept your idea. They will say, we don't understand what you are saying. We don't accept what you are saying. So you must have to have the guts to say, okay, it will work. Don't worry. Please give me some time. Or give me some fund. I will show you it works. So that kind of self-motivation is actually the main driving force behind technological innovation. Okay, so let me stop this presentation first. I'm sorry, I'm not familiar with this Zoom. I always use WebEx. Where is your okay. So let me give a very simple example of trees. Can you see the slide that I'm showing now? Is there anyone can tell me?
Yeah, it's visible, yes.
Okay. Okay. You see that there are some seat arrangement. Probably it is in the aeroplane. And this is symmetric. All seats are aligned in a specific way. This is little bit away from symmetry. Hello?
Ajit sir, okay, sir.
Okay. And this is more asymmetric. This one more asymmetric than the previous one. This one also more asymmetric than previous one. And this one is much more asymmetric than the previous one. So this is one of the principles of trees, that you break symmetry. If you break symmetry, what happens? You get more space here. If you compare, you have less space, leg space. Here you have more. So this is the arrangement of seat when you ride on an aeroplane. This is the trees is saying that if you do that, you will have a lot of space in the eye. If you break the symmetry, or even if you do like this, you will have more space. So you can carry more passengers in your airplane. So here, we are not thinking about any theoretical things. We are just saying that we have to break symmetry. So if I break symmetry, I will go for asymmetry. And if I be asymmetric, I will be able to get much better solution. So this is one of the principle of trees. So this way trees is giving you 40 principle. Trees is giving you 40 principle, and 12 of them are general. And trees is saying that engineer, when they solve problem, they have 39 parameters only to think about. And there is a conflict between parameters. So if you can resolve the conflict among these 39 parameters, you can get a better solution. So how to solve the conflict? Use one of or some of the principle out of this 40. So this is what trees is saying to us. So the engineer is thinking about only 39 parameters: weight of moving object, weight of non-moving object, coming down to productivity. So there are only 39 parameters. And we have the conflict between this, say, weight of moving object. You want to make it better. It will make a problem with length of moving object. So in that case, you have to use principle number 15, 18, 29, and 38. So if you use this, one of the principles written here, you will be able to solve this contradiction. So, so for new engineers, I would recommend you play with this contradiction matrix. Try to find out a parameter that is compatible with trees, and see how this parameter is making conflict with other parameter, and try to figure out which principle you need to use in order to resolve this contradiction. So let me give you a real life example. This is a work we did many years back with Hitachi Mitsubishi Tool Engineering. Now probably the company name has changed. So we try to develop cutting tools for milling operation. And how should we invent new milling tools? One of the problems one of the problem that when we machine, particularly fixture or mold, dye and mold industry, the shape is very complex. So when we machine a die or mold, our cutting tool pass many complex area where you have to turn your cutting tool, like this one here. We have to pass this corner. So when the cutting tool pass this corner, your cutting force become very unstable. So what do? When it pass the corner, you reduce the speed. Okay. So if you reduce the speed, your productivity will go down. So how do you solve this problem? Okay. So industry people, as I said, they're very much fond of trees. So what we found is that it is a problem of
Now, okay, disconnect.
disconnect. Okay. So I will upload my file again.
Okay, sir.
Can you see the file?
Yes, sir.
Okay. So we would like to improve the parameter 35, which is adaptability, meaning that my cutting tool should perform properly all over the area of my cutting area. And parameter to be sacrificed, we sacrifice our speed, as I said, due to instability in my cutting force. We don't want to break my toe. So we become very slow. So if we become very slow, then the whole process becomes slow, then my productivity goes down. Okay, so this is a problem between 35 and 9, speed and adaptability. So if I would like to solve this contradiction, Trees is saying, hey guy, you use principle number 35 or principle number 10 or principle number 4. So principle number 35 is parameter change. Principle number 10 is preliminary action. And principle number 4 is curvature. So we thought that we have nothing to do with principle number 35. We have nothing to do with principle number 10. We can do something about principle number 4. So we selected this principle, curvature. Okay, so the cutting tool that we have now is circular in cross section. So it has a fixed curvature. So we said that, okay, why not we change the curvature of the tool? So we said that we will not make a cutting tool which cross section is circular. We will make a cutting tool which cross section is oval shaped, elliptical shape. So we will have a minor diameter and major diameter. That means our curvature is not fixed in that particular cross section of my cutting tool. So if we invent this cutting tool, we see that instability is gone. So what we did, we didn't become knower. We become doer. We say that, okay, we will not use the circular cross-section cutting tool, which is in the market. We will invent a new cutting tool, which has a oval-shaped cross-section. So that solved our problem. And we did some experiment and we showed that, okay, our idea works. Okay, this is one of the example of trees that we applied many years back, and this is an open access article you can go and download and see. Okay. So, a driving force behind technological innovation. Become doer. Do not bother about becoming a knower. Knowledge will come after, not before. Okay, this is the message that I would like to give it to you today. So I would like to keep this floor open for you to ask any question that is coming to your mind. Thank you, Mr. Chairman.
Okay. Thanks, Professor Sharifullah. The floor is now open for questions. I think, sir, the question could be asked in Bangla as well, I think.
Yeah, no problem. Bengali.
Okay. So the floor is open, so anyone can ask question in English or Bangla, whatever. It's okay.
Yeah, আপনারা বাংলাতে কথা বলতে পারেন, কোনো অসুবিধা নেই।
Is there any question? You can write in the chat box if you like. In the chat box.
ইনোভেশন নিয়ে এখন তো অনেক কথাবার্তা বলা হচ্ছে, কিন্তু যখন ইনোভেশন নিয়ে কোনো কথাবার্তা বলা হয় নাই তখনও তো ইনোভেশন হয়েছে স্যার।
এক্স্যাক্টলি। যখন পৃথিবীতে বড় বড় ইউনিভার্সিটি ছিল না, তখনও মানুষ অনেক কিছু করছে। সো এটা একটা রং পারসেপশন মানুষকে দেওয়া হয় যে the more you learn, the more you can innovate. My study shows that this has nothing to do. In my lab, I saw there are many students who cannot even write down a differential equation. But their achievement as a research output is 1,000 times better. So, frankly speaking, knowing doesn't make people innovative. So, you need a completely different mindset when you serve an industry or even in your or any organization. So you have to be a doer, and for that, as I said, trees could be your first step. You learn from trees, then we have many other. Say Dr. Mamun did his PhD on CK theory, concept and knowledge theory, that we are working on for a long time. CK theory is much better than trees. And there is another theory we call axiomatic design, which was developed by Professor Nam Su at MIT. So there are many other theory that will make you doer, not a knower, at the beginning. Okay, I'm also an academician, and my job is to teach students. I always say that whatever I teach, it is just for making money for me, not for your sake.
এখানে আরেকটা কোশ্চেন করি স্যার, আমরা যখন টিকিউএম পড়াই স্যার তখন বলি যে ডুয়ার হওয়া যাবে না, ডুয়ারের চেয়ে পারফর্মার হতে হবে স্যার, এটা বলতেছে স্যার। টিকুএম যখন আমরা পড়াই তখন এই কথাটা বলি যে ডুয়ার মাচ বেটার দেন মানে পারফর্মার হতে হবে। ডুয়ার হচ্ছে আপনি তো
Performer and doer, what is the difference, Dr. Mamun?
ডুয়ার মানে কাজটা কমপ্লিট হলো না, জাস্ট করতেছি এরকম অবস্থা, মানে আর পারফরম্যান্স একদম ডান, ওকে শেষ।
So in the theory of innovation, there is nothing called perfection. Okay, probably for quality control, it is you have to be perfect. You have to fulfill the requirements of your customer. So that's why you are saying this. But for innovation, say for example, if somebody asks you to give a new idea of quality control, okay, so in that case you have to be a doer. But if somebody asks you, okay, you apply the current theory of quality control, then the question of performance is coming.
Okay, so thank you, sir.
I could answer you.
Okay, sir. Okay, sir.
Okay, I have a question from my side that
Yeah.
yesterday Professor Nawaz Sharif, he mentioned
Yeah.
about technology innovation, and he talked about there should be a mingling of industry people, academic people, business people, different segments of the people. So do you suggest anything like that? Say, as you said, that the people should be doers. So those who graduated or those who are studying in the university, they should mix more with actually those who are the doers, actually those who are doing the business. And by this way, they can get some interactive learning or.
Okay, I understand Professor Nawaz Sharif. Professor Nawaz Sharif is saying we must have data, then information, then knowledge, then we will have wisdom. So this is his thinking. I am saying you go reverse. You already have your wisdom. From your wisdom, you create knowledge, and then you create information, and then you get your data. So to make it reverse, maybe sometimes it's good that you have some collaboration with industry. So in our study, we didn't find any strong reason that innovation must have to be with industry university collaboration. Industry people, why they actually come to university? The simple thing, they want to make money. The fund is given by the government. Government will not give them money directly because government will give research fund to non-profit organization like universities. And they would like to, business guys, they would like to tap this money. So they are trying to get some fundings, government fundings indirectly through collaborating with the university.
Thanks.
But who is actually making this breakdown? Who is bringing this innovation in the whole process? You never know. Maybe it is the guy who is in the university, or maybe it's the guy who is in the industry.
So you're suggesting that whoever in the industry or university, they should first do, and then reversely they will go to the knowledge.
Exactly.
And
Exactly. If you want to say that, look, I will innovate, you have to do something first. It can be a researcher or a manager in a company, or it can be a professor or a student in the university.
And any suggestions that how that could be fostered, like Now the students are asked to do some capstone project or real life projects, or
Yeah.
in every course they need to do some projects. And reversely, in the industry, how they can foster this culture of innovation in the industry.
Well, anywhere in the world you go, innovation is everywhere. Whether sometimes you acknowledge, you write it down, or you post in the newspaper, sometimes you don't. But innovation is basic human instinct. It's everywhere. Now, for your academic purpose, like you have students who will do some thesis work, this is what you want to mean, Doctor?
Yeah, yes, sir.
Yeah. So probably you will try to see whether or not he or she can apply the knowledge they gain. If you do that, there will be no innovation, or a very little amount of innovation.
So what they could do, so in that case,
I mean, if innovation is not so important for you, you don't let them to do that.
Oh.
If you think that innovation is very important for them, then as I said, you ask them to follow trees or any other innovative theory,
okay.
and let them come up with something completely out of box.
Okay.
But if you say, for example, you teach them a theory of your, say, supply chain, and ask them to apply those theoretical equation to explain what is going on in the garment industry supply chain. So they will be absorbed by those equations. They will try to impose their knowledge. Okay, they will never be able to solve problems, because the problem never studied in any university. We studied in the university, so problem has no knowledge. We try to impose our knowledge to the problem. So this is a completely different way of you have to think. For example, in Indian subcontinent, British, they give us railway, right?
Right. Yeah.
At the same time, Japan got the railways from the UK. Now, Japan is selling high-speed rails all over the world. We cannot.
Yes.
Why?
Oh.
So somewhere we stop the process of innovation in our society. I would say your society, because now I'm Japanese. I'm no longer Bangladeshi.
Yeah. Okay.
So this is a very what do you call, a difficult thing in our post-colonization society. We never allowed any innovation. That's why we're falling behind.
Thanks, Professor Sharifullah. And I think we, in our participant, we have some people from industry, like Bebza, and somewhere like IBAX. So
okay, I see one question from the chat box. Someone is saying the Hegel's idea of idealism, pragmatism, etc. I would recommend, please go through my paper. I wrote a paper called What is Knowledge in Industry 4.0. It is open access, published by Willie. What is knowledge in Industry 4.0? In that article, you will be able to find out the difference between idealism, realism, and pragmatism, clearly written. And I published one book called Concept Map and Knowledge. In that book also, I talked about this. So you can download. This is also open access. Okay. So that is very important, that idealism, realism, and pragmatism, we realize in our mind, and we do our innovative job based on that. So I think my time has run out.
Yes, almost.
Almost.
We are just 3 minutes left. So
Okay, please go ahead and ask any question.
Any question? আমাদের অডিয়েন্স থেকে কেউ একটু কোশ্চেন করতে পারেন, ইন্ডে ব্যবসা বা এনবিআর বিভিন্ন জায়গা থেকে আসছেন যারা। কেউ করবেন? যেমন
এনইপিডির একজন আছে।
জি,
এনইপিডির।
Sir, I have asked a question and sir gave the answer, sir. Thank you. In chat box, I have asked the question that sir mentioned many, actually not many, some driving force, 3 driving force. One of them is idealism. So I actually, I have completed my master's from policy. That's why I actually studied the Hegel idealism. That's why I asked actually, sir, your idealism, that means here you actually mentioned, and the Hegel idealism, is there any difference, or you actually followed the specific areas of those specific traits of idealism or not?
Okay.
That's my point actually.
What I said is that idealism, realism, you have to avoid if you want to be innovative. Okay, this is what I'm saying. It can be Hegel's idealism, or it can be a religious idealism, whatever. Okay, so there are a lot of debate about idealism in the epistemology or philosophy. So you just ignore all those. Okay, pragmatism is the most important. It seems to me, this is very important for innovation. Okay.
Sir, pragmatism, you actually like to use this term for the postmodern period, not for the modern period, because pragmatism, the part is actually we have found in postmodern period. Am I right or wrong?
Pragmatism was everywhere,
But
from the very beginning of our civilization. Otherwise, we couldn't invent. So,
but
postmodernism, modernism, these are all European
concepts, sir.
sort of idea. So
Right, sir.
I don't buy those ideas.
Okay, I got your point, sir. Thank you, sir.
Okay, thank you very much for your questions, and we'd like to thank again Professor Sharifullah for his presentation, and we got to know about the problem solving